Hi, Dr. G here. I am going to do a little review of the regular sine of x and cosine of x curves to show you side by side what they look like and all the features that you really need to remember and internalize and be able to use in order to get other variations of these two curves. So it's really important. And then after we go through the basics, we're going to do a couple of examples of transformations of the cosine graph. Okay, so it's really important that you understand the basics and know all the differences between these two curves. So first of all, they have a lot of similar features. One is they both have amplitude 1, so the highest and the lowest y-coordinates of either of these graphs will be 1 and -1. And they both have period 2 pi. And that means any cycle will be of length 2 pi. And so if we start a cycle at 0, x equals 0, then we only need to go as far as x equals 2 pi. So we usually do that just because 0 is an easy number to work with. So we go from, one cycle will go from 0 to 2 pi. And then when we need a larger interval, after we graph one cycle, then we can graph larger intervals because we just repeat that graph. All right, so let's start with the sine curve. Setting up our axes, we know we're going to go from 0 to 2 pi, so we start marking off the x-axis. And the y-axis will never go below -1, will never go above +1. We've got a couple other key points in here. So notice we have 4 little subintervals: 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and then 3 pi over 2 to 2 pi. Those are our 4 subintervals. Now, another feature you need to remember about the sine curve is that it starts at 0, right? Because sine of 0 is 0. So the y-coordinate of the starting point is 0. So we plot that point, and now remember, it always ends where it starts because it repeats every 2 pi units. So we can plot the ending point. 2 pi has the same y-coordinate 0. And then remember that the sine curve actually has one more x-intercept in that cycle. The x-intercept is the midpoint between these two guys. So at pi, sine of pi is also 0. So at pi, we cross the x-axis. Now, what does it do in between the other two key points, pi over 2 and 3 pi over 2? Well, that's where the graph hits its highest and lowest points. How do we know which one, when it hits the highest one and when it hits the lowest one? Well, remember, as x increases from 0 to pi over 2, sine is increasing from 0 to 1. The sine of pi over 2 is 1. So you hit your highest point at pi over 2 and your lowest point at 3 pi over 2, and you can connect the dots. So notice the basic sine graph goes up, goes all the way back down, and back up again. Starts at its sort of midline. The midline would be the x-axis. It starts there, goes up to its highest point, back down through the midline to its lowest point, and then ends once again at the midline. The cosine, however, looks different. It doesn't have 3 x-intercepts in one cycle. So let's set up our axes for the cosine. We still have amplitude 1. Let's put in the same key points, right? You take your cycle, 0 to 2 pi, divide it up into 4 subintervals, and you get 5 key points. So the cosine graph doesn't start at its midline. It starts at its highest point. So at x equals 0, the cosine of 0 is 1. So we plot the point on the y-axis at 1, and then it has to end at the same place. So when you get to x equals pi over 2, your y-coordinate is also +1. And then in between those 2 points, at the midpoint, pi, the cosine curve hits its lowest y-coordinate. So it's way back down there at -1. And we can see that it had to cross the x-axis to get there, and then it has to cross the x-axis again to get back up. So we've got two x-intercepts at pi over 2 and 3 pi over 2. And notice when we connect those dots, we don't have two turning points. We have one turning point. We have, instead of two little sort of half humps, we have one big hump, right? It starts out at its highest y-coordinate, ends at its highest y-coordinate, and it only hits its lowest y-coordinate once at pi. Cosine of pi is -1. So take a look at those differences between those two curves. Two humps, two little humps versus one big hump. All right, so now let's do a couple variations on that cosine curve to see how to use these features and how to make these transformations that we're going to do. So first we're going to graph y equals -2 cosine of pi over 9x for x values between -18 and +18. So first of all, we don't know if that's one cycle. We don't know what the period is. If that's not one full cycle, that we will have to graph one full cycle and then maybe extend it, right? We don't know. So first, we're going to find the amplitude and the period, and when we find the period, we'll be able to figure out one cycle and our 5 key points. Before we do that, first notice that we have a minus sign outside of the cosine. So that means we're going to have a reflection, a vertical reflection across the x-axis. So our hump, instead of going down and coming back up, it's probably going to go up and come back down. That's the difference visually. But also the 2 means we're stretching it a little bit. So the amplitude is different. So let's start looking for the amplitude and the period. The amplitude, remember, has to be the absolute value of the number in front. So in this case, our amplitude is +1. And for the period, always, always, always put your argument in between 0 and 2 pi, because the regular cosine function has one cycle between x equals 0 and x equals 2 pi. So for this cosine function, the argument is pi over 9 times x. So let's put pi over 9 times x in the middle. So when we solve for x, we'll not only get the period, we'll get one entire cycle. So to get x isolated in the middle, we got to divide everybody by pi over 9. Now, in the middle, the pi over 9's just cancel. We just get an x. And on the left, any 0 divided by anything is just 0. But on the right, just to simplify our work, dividing by a fraction is the same as multiplying by the reciprocal of that fraction. So instead of dividing by pi over 9, I can call that multiplication by 9 over pi. So division by pi over 9 is the same as multiplication by the reciprocal. So now the pi's will cancel, and we'll just have 2 times 9 over 1. So that will be +18. So now not only do we know the period is the bigger number minus the smaller number, which is 18, but we also know one cycle. So one cycle of our graph is going to go from x equals 0 to x equals 18. And that's nice because we're looking for the graph between -18 and +18. So if we get one cycle, we're half done. Then we just extend it. So we've already got 2 of our 5 key points as well. 0 and +18 are 2 of the 5 key points that we need. So let's start setting up our axes. So we know we're going to go from -2 to +2 on the y-axis. The x-axis eventually is going to go from -18 to +18. But we're going to do one cycle first. So we're going to start at 0, and where are we going to go? So let's see what our other key points are. So we're going to go from 0 to +18. So the other 3 key points are going to be midpoints. So the midpoint between 0 and 18 is 9. That's halfway. To get the midpoint between 0 and 9, we just add 0 plus 9, divide by 2. So that's 4.5, or 9 over 2. We don't use mixed numbers in college math. I don't know why people use them in high school, but just leave it as 9 over 2. And then the other one is going to be 9 plus 18 divided by 2. So that one is 27 over 2. So those are the 5 key points. And we got that by finding the way that we found the period. All right, so let's mark our x-axis with 9 over 2 and 27 over 2. So now we're going to graph one cycle. We know we're going to go up and come back down, or down and back up. Let's figure out our starting point, and then we'll have everything else will be easy. So the starting point is always, for the cosine, is always its highest or its lowest point. So we're either going to start off at positive 2 or at negative 2 when x equals 0. So if you want to check, I mean, we already said we were going to do a reflection, so instead of going down and coming back up, it's probably going to go up and come back down. So we think we're starting at negative 2, but let's just double check. If you plug in x equals 0, you're taking negative 2 times the cosine of pi over 9 times 0. Well, pi over 9 times 0 is 0. And the cosine of 0 is 1. So you're taking y is equal to negative 2 times 1, which is negative 2. So yes, you're starting at negative 2, which is what we thought. That was our intuition. And that means we have to end at negative 2. So there's the other point at 18, negative 2. Halfway in between, we got to hit our highest point. I don't need to plug anything in because I know what the cosine graph looks like. We're going to go all the way back up. We're going to go all the way up to 2 when we hit x equals 9. And then the other 2 key points, well, those are the x-intercepts. That's where we have to cross the x-axis to go up and come back down. So notice I didn't really have to plug anything in except maybe 0 at the beginning just to verify my hunch. My hunch was that I was going to start at negative 2, but I just wanted to kind of verify that. So I plugged in x equals 0, and I did get negative 2. And then the rest, I didn't need to plug anything in. I knew that at the end of my cycle, I was going to end at negative 2. Halfway in between, I had to go all the way up to positive 2. And then the 2 x-intercepts were between those lowest and highest points. So connect those dots. And now, to get the rest of the graph, we're just going to repeat that hump on the left. So mark off a couple of tick marks. You don't really need to label them. And put your dots where you know they have to be. And connect them. And there we have it. We haven't made a table of values. We haven't really had to plug in more than one number. But we did find 5 key points. Okay? So, on the test, I'll be looking for your 5 key points and your one cycle. Okay? So make sure I can find it. Let's do one more. This time, let's just graph one cycle, one complete cycle of y equals negative 2 minus cosine of 2x minus pi over 2. So this one's a little more complicated, but we're going to do the same steps plus a couple of more. Because we see that we're adding something outside of the cosine and adding something inside the cosine, we're going to have a vertical and a horizontal shift. So we'll find those. So first let's start with the amplitude. The amplitude is the absolute value of the number in front of the cosine. So the amplitude is 1. The period, we're always going to put our argument in between 0 and 2 pi. And that's because it gives us a lot more than just the period. It gives us a lot more information. So we do this not just for the period. All right, so to solve this for x, we first have to add pi over 2 to everything. And then we're left with 2x in the middle. Pi over 2 is the low end. The high end is 2 pi plus pi over 2, which turns out to be 5 pi over 2. Now we have to divide everything by 2, and we know that's the same as multiplying by 1/2. So we have x in between pi over 4 and 5 pi over 4. So we can tell that our period is going to be the bigger number minus the smaller one, so 5 pi over 4 minus pi over 4, which is 4 pi over 4, which simplifies to pi. But that's not all we get. We get one full cycle will have to be between pi over 4 and 5 pi over 4. So we've got 2 of our 5 key points. The other 3 key points we can find by finding the midpoint. So what's halfway between pi over 4 and 5 pi over 4? Well, you could add them and divide by 2, but you can think of that as a 1 and a 5. What's halfway between a 1 and a 5? And the answer is 3. So the midpoint is just 3 pi over 4. And then the other 2 points are easy to find. What's halfway between 1 and 3? 2. So 2 pi over 4 simplifies to pi over 2. And then halfway between 3 and 5 is 4, but 4 pi over 4 is just pi. So we've got our key points. 5 key points. So what else do we have to find? Now, before we start graphing, we should find those shifts. So the horizontal shift we can get by looking at where the cycle started with the regular cosine and where it ended. Where the regular cosine cycle starts and ends, and then where our new cycle starts and ends. So the regular cosine cycle starts at 0 and ends at 2 pi. But our new function starts at pi over 4 and ends at 5 pi over 4. So visually, we can see the horizontal shift went to the right. And it went exactly pi over 4 units to the right. So the horizontal shift, the magnitude is pi over 4. The direction is to the right. So you could say pi over 4 units to the right, or you could say right by pi over 4 units. So that's our horizontal shift. It's to the right. And we can visualize it by looking at what happened to the cycle, the starting and ending points of the cycle. All right, so the horizontal shift, we can use the equation to find that. So I'm rewriting the equation, and we can see that the only thing that's added to the outside of the function is -2. That means that all the y coordinates are getting a -2 added to them, or basically getting a 2 subtracted from them. So each y coordinate minus 2. So that means we're shifting all the points down by 2 units. So the direction is down and the magnitude is 2. So down 2 units, or 2 units down. All right, so now we're ready to set up our axes, our frame. So I can tell, so let's first mark off our x-axis with our 5 key points. And notice I'm writing my numbers above my x-axis. And that's because I can tell that my highest and lowest points are both negative. So the highest point of the regular cosine function was +2, right? But now you got to shift that down 2 units. So +2 minus 2 is -1. So my highest point now for my new function is -1. And the lowest point, well, that got shifted down. So the lowest point for the cosine, regular cosine, was -1. But when you subtract 2, you end up at -3. So everything I can see in advance, everything is going to be below the x-axis. So that's why I drew my axes like this. I'm not going to waste all that space by having a bunch of blank space above the x-axis. All right, so the other thing I know is that the midline is no longer the x-axis. So I'm not going to cross the x-axis at all, but I can think of the x-axis as being sort of this invisible line that got shifted down 2 units. So I'm drawing a dotted line through -2 because that I can think of as my sort of midline, the middle of my graph. And notice the amplitude, it's still 1, and 1 is the distance between my midline and my highest point, or my midline and my lowest point. So the amplitude is this distance right here, or this distance right here. That's my amplitude. All right, and now we're going to start plotting points, but we don't really have to plug anything in. So we know that we're going to start at x equals pi over 4. Now that, because it's a cosine, that is either going to be, the y-coordinate is either going to be the highest point, -1, or the lowest point, -3. Well, how do I know whether I'm starting at the highest point or the lowest point? Well, for the regular cosine function, it starts at its highest point and goes down. But here, we have a reflection. So if you look at the equation, that minus sign in front of the cosine means we do have a reflection. And so that means we're going to be starting low and going up. And if you just want to verify that, you can go ahead and plug in pi over 4, and you will get -2 minus cosine of 2 times pi over 4 minus pi over 2, and you will get -3 if you do that. So I'm going to plot a point at x equals pi over 4, y equals -3, because that's my starting point. Now, I don't need to plug in any more points, because I know that it ends exactly where it starts. So at 5 pi over 4, the y-coordinate is also -3. So I plotted the ending point just based on where the starting point was. And then halfway in the middle, it has to go to its highest point. So at 3 pi over 4, the y-coordinate is -1. And then I know the other 2 key points have to lie on the midline. And I can connect the dots. And that's it. That's one cycle of that curve. All right. So I've done 2 examples of the cosine because it looks very different from the sine graph. So practice, 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 and I will see you later.